Today we will apply our understanding of the rules for adding and subtracting integers to other rational numbers. Remember, a rational number is any number that can be written as a fraction. So let me have you write at the top here just some information about rational numbers. So let's start with the key term, rational number. We'll underline it, okay? And then you're going to write any number that can be written as a fraction. Okay, and then we're going to go ahead and write down a few examples. Okay, so example 1 would be any integer is rational. For example, if you have the number -5, that can be written as -5 over 1. So -5 is rational because the value -5 over 1 is still -5, and it's written as a fraction. Another example would be fractions themselves. So obviously, if you have a fraction like 1/2 or 1/3, that is a fraction. So you can write it as a fraction. It is a fraction. So that is rational. A mixed or a complex fraction like 1/3 over 1/5 can still be written as a fraction. We'll get into those more complex types of fractions in, I believe, Unit 2. But again, that would be rational. And then another example would be some decimals, like 9.6. That's a terminating decimal, and we can write that as 9 6/10. It could also be a repeating decimal, because repeating decimals can also be written as a fraction. This would be 1 1/3. So 1/3 is 0.3 repeating. So any of these examples can be written as a fraction if they aren't already. So those are all examples of rational numbers. Okay, and in this section, which is section 1-5, we're going to see how the rules for adding and subtracting all rational numbers, again including integers, fractions, and certain types of decimals, are the same as those for adding and subtracting integers. So let's think about some of the rules, right? If you are adding two negatives, you add and keep the negative sign. If you're adding two positives, you would just add and keep the sum positive. If you have opposite signs, remember there's that cancellation that occurs, so we subtract your two numbers and then keep the sign of the larger absolute value. And of course, if you're dealing with a subtraction problem, whether it's just integers or other rational numbers like fractions and decimals, you need to keep change. Use the additive inverse, and then use your addition rules. The other thing we're going to focus on in this section is that the distance between any two rational numbers, and they're just going to give letters here because they're unknown. This is just sort of in general. P and Q on a number line is the absolute value of their difference. So in this example here with the number line, they're giving you some number P, which is at the value -5, some number Q, which is the value -2. If you want to know the distance between those two numbers, you are going to subtract. So you'll see I have the -5, -2. Right here they're written, and then I'm going to put the subtraction sign in the center. Okay, you can also write this sort of in the opposite, switch the numbers so that we start with our -2 instead, and then subtract from that the -5. So when you're talking about distance, it doesn't matter where you start. It's like if you measured a room. If you start on the left and measure toward the right, you would get the same answer as if you measured with your tape measure from the right of the room to the left. So you can change the order of those numbers, but since it is a distance problem, it is a subtraction problem. Okay, we're going to move to the Do You Understand section and begin with the essential question. So this section's essential question is, how are adding and subtracting integers related to adding and subtracting other rational numbers? So I already explained to you in our introduction in this video, but now I'm going to give you a few moments to write down that information. So again, the rules are the same, whether you're working with integers or other rational numbers. They're all rational numbers, so the rules will be the same. If you are adding or subtracting with the same sign, you add and keep the sign. If you're working with different signs on your integers or rational numbers, one's positive, the other's negative, you need to subtract those numbers and then use the sign of the absolute answer, the absolute value in your final answer. Okay, the next question is a reasoning question. It says, when finding the distance between two rational numbers on a number line, does the order of the numbers you subtract matter? Explain. So this is my example of measuring, the room. Maybe you're measuring the length of a room. It does not matter if you start from the left and go to the right or the right to the left, you're still going to end up with the same distance. And that's because if you take the absolute value of your difference, you always get a positive distance. You're talking about how far away or how, far is the left side compared to the right side. You would never talk in the negative when talking about distance. So here's the example. If you have 3 minus 1, you're going to get a positive 2, and the absolute value of positive 2 is 2. And if you switch the order of your numbers, so this would be like from left to right, but now we're switching the order. Maybe we're going from right to left. So we have 1 minus 3. That would give us a negative 2. But the absolute value of negative 2 is a positive 2. So the distance, no matter which way you start and where you end, will be the same, and it will be positive. Okay, number 3. Critique reasoning. Gwen says that the sum of -1 3/4 and 2.5 is the same as the difference between 2.5 and 1 3/4. Is Gwen correct? Explain why or why not. So take a moment, write that down, and then I'll provide and show you how you would set these up to get to this answer. Okay, go ahead. So to find the sum of rational numbers with different signs, you find the difference of the absolute values and apply the sign with the larger absolute value. Okay, so here, I guess I could fit this right here. If you have negative 1 3/4 and you add that to 2.5, you would get 3/4. Okay, and that's because when you have opposite signed numbers, you do need to subtract. So one way to look at this is switching the numbers, because negative 1 3/4 is like subtraction. So you could use the commutative property. You can also find the absolute values and then subtract, and then keep. We know that the answer is going to be positive because 2.5 is farther from 0. Okay, so if I switch the order here and I do 2.5 minus 1 3/4, I also get, I'm sorry, this would be 1/2. I had 3/4 in my head. All right, so it's, oh, nope. Sorry, we're switching these. All right. Yeah. So we're switching the order here. So the 2.5, and then we're bringing the negative 1 3/4 to the back, which is the same as subtracting 1 3/4. So we get the same answer again. So it does have the same value. Okay, number 4, under the do you know how, we have an example here. This guy is going fishing, and the top of his fishing pole reaches up here 8.5 feet above the surface of the water. And there's a fish under the water, and that is a distance of 2.5 feet below the surface. So remember, when we talk about the surface of water, that would be 0 feet. Okay, and to understand this problem, we're going to really focus on this word here, distance. And the word distance sort of rhymes with difference. I mean, they're really close. I wouldn't call them exactly rhyming words like pie and sky, but they are very, very close in how they sound. And whenever you're finding difference, you are subtracting. So when you have a distance question, you are also subtracting. So these 3 words are all equal, okay, telling you what you need to do or what we might be trying to find. Okay, so with this one, we want to find the distance between this point here and where the fish is. So we have a distance of 8.5 feet and then another 4.5 feet. So because it is a distance question, we're going to start with subtraction. So we have the 8.5, that's positive because it's above the surface. Subtract is distance. And the other point here is below sea level, so this would be a -4.5. Now to solve this problem, especially without a calculator, you're going to remember your rule with subtraction. You want to turn it into an addition problem using the additive inverse. So we are going to keep, change, change. Those are sort of your commands or your directions for additive inverse. So we will leave the 8.5 the way it is. We're going to go ahead and change that subtraction to addition, and we're going to change the negative to a positive. So this problem is now 8.5 plus 4.5. Well, adding 2 halves are easy because you get a whole. So your whole numbers are 8, 4, and then the 2 halves would give you an extra whole. So we have a total of 13 feet from the top of the fishing pole to the fish. And since we are working with distance, that is a positive 13 feet. Let's just plug that in. The total is 13 feet. All right, number 5. A shark began at 172.5 meters below sea level and then swam up 137.1 meters. Where is the shark's location now in relation to sea level? With word problems, one of the key strategies to use to help you understand the problem is drawing a picture. So we'll start with sort of this wave here, like our surface of the water. We're going to label it as 0 meters. So 0 and m for meters. I'm going to draw a vertical number line. And the shark began at 172.5 meters below sea level. So that would be under the water. And these, of course, would be negative numbers because it's below 0. So this would be negative 172.5 meters. And the shark from this point is going to swim up 137.1 meter. So going up would be a positive. So what we're trying to find is its new location, which will still be below sea level, okay? But we want to figure out where is the shark now. So if we turn this into an expression, we would have our starting location for the shark. And since it's going to move up, that would be represented by a positive 137.1. Now, because we are adding, we don't keep change. It's already addition. There's nothing that we need to do. Like up here, you only change subtraction to addition. But once you are already in addition, you're going to follow your addition rules. So when you have numbers with different signs, you do need to subtract your two numbers. So we're going to drop this negative because we subtract their absolute values. So 172.5 minus 137.1. Notice that I'm lining up all my place values. So I lined up my tenths, I lined up my ones, my tens, and my hundreds. Okay. In the answer, your decimal will also be lined up here. Okay. And when you subtract, you get 35 and 4/10. So that's its new location here, and it's underwater, so it's a negative 34, negative 35 and 4/10 meters. So that's the thing you have to remember. We were working with absolute values, so our answer will be positive in the work that we're showing. But when we write our final answer and circle it, we need to remember to put back that negative sign. So you could write it as negative 35.4, and it's understood that that negative means below sea level. If you choose to sort of write a sentence about the answer, you would say, so two different ways, you would just say 35.4 meters below sea level. And by writing below sea level, it is understood that that is a negative 35 and 4/10. Okay, now moving on to the last two examples. Okay, so I'm going to do one again, and I'll give you a few moments. You'll try letter B on your own, and then we'll provide you with the answer to that. So, there's a lot going on here in this little workspace. So let me just, section this off a little bit. So A will go here and B will go there, just to try to stay organized rather than trying to squeeze it all in there. Okay, so A is negative 12.5, and we're adding 4.5. Okay, now it's already addition, so I do not do the keep change. I leave it how it is. But now that I know it's an addition problem and I have opposite signed in numbers, I have to subtract. So 12.5, of course I'm subtracting their absolute values here. 1/2 minus 1/2 is 0, so those will cancel, and I'm left with just subtracting my whole numbers, and 12 minus 4 is 8. Please take a moment and complete letter B on your own in that workspace, and in about a minute, we'll go over that answer. Okay, so I just rewrote the problem here, and since it is a subtraction problem, I need to keep change, apply the additive inverse. So the minus or the subtraction becomes a addition symbol, and the negative becomes a plus. Again, I have opposite signed integers. I'm sorry, numbers. These are not integers, but they're other rational numbers. So I'm going to subtract the two numbers, and I get 0.10. Since there are no hundredths, I could just simplify this as 1/10, and the negative number here is the greater absolute value. So this would be a negative 1/10. This ends the lesson on section 1-5, adding and subtracting rational numbers.